we go. Thank you very much. I'm going to cover somewhat briefly some advice for electrical engineering master's students. It also will help for those who are viewing that are PhD students as well. Keep in mind that what I'm covering is generally for everybody. So if you've done this in the past, some of it may be new, but this is also going to be covered for new students. So as example, hey, welcome to UNC Charlotte ECE department. I am Professor James Conrad, jmconrad@uncc.edu. I was going to do PowerPoint on this, but I didn't get to it yet. So advising. If you're going to be taking courses in fall 2016, obviously, you need to identify those courses and to register for these. For those of you who it is their first semester, you do not need to fill out this form. For those of you who it is your second or beyond semester, you need to fill out this form. So you've probably seen this before. This form is available on the department's webpage. It is a PDF form. You could type it in. And as I've mentioned to you, I will advise you some. I'll talk to you some as well. I'll pretty much sign anything you put in front of me as long as it doesn't say that I'm your advisor yet, all right? So don't forget, fill out this form, bring it in, and you can either hand it to me and I'll sign it, or you can slip it under my door, I'll sign it, and release your hold. The first day of registration is Monday the 28th. I believe it's 11 a.m., correct? So on the back of that advising form, I provided for you a list of the graduate classes that master's students can take. If you're a PhD student, you will actually have some courses there. Instead of the 6,000, you'll choose the 8,000 version. But wow, look at all those courses offered in computer engineering. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 computer engineering courses. Well, that's pretty good. And we have in communications 1, 2, 3, 4, 5 communications courses. So if you're in the general realm like you here, and you're taking computer engineering and communications and controls and other courses like that, plenty of offerings, right? In fact, just as a poll, how many of you are in advanced embedded operating systems this semester? Oh, it's not offered this semester? Okay. I forgot about that. That's right. How many of you are in the regular RTOS? All right. You can take the advanced RTOS now. And that might be a really good course to take. How many took RTOS last semester? All right, whoa. So it just looks like almost everybody in this room can take the advanced RTOS class to get more of the experience in developing a Linux kernel. Good course, I hear. A lot of people, in fact, a lot of people, from what I understand, have gotten jobs because they've done this. So you might want to look at that. Research tools and techniques will be offered by Dr. Sass. There's also Internet of Things. I sure hope that nobody in here takes embedded systems, because if you're in advanced embedded systems and you're in here, something went wrong. But those of the people viewing, that is one of the courses they really need to look at, is embedded systems. The other is research tools and techniques, are especially for people who are starting out next semester or in the fall. And then some other additional course. I would actually recommend real-time operating systems if this is your first semester. There are a couple other courses. There's one up there called Embedded Signal Processing, which I predict will fill in about 20 seconds when registration opens. That course really should be taken by those of you who have taken digital signal processing already, or have a really good idea on digital signal processing skills, and who have taken embedded systems. Obviously, those in this room have. Very hands-on. You'll be required to buy a board. Have you heard good things about it? Well, it's a really good hands-on class, so think about that. Wireless sensor networks is also another popular class. You actually do hands-on work with wireless sensor networks. It is extremely likely that we will hire a new faculty member in computer engineering in the fall. Right now we are actually interviewing some. We may hire 1 or 2 new faculty members. And if they do come, there will be additional courses that will be available for you to take in the fall semester. Many of you here in this room aren't taking energy and power, or I doubt anybody in this room is going to be taking applied quantum mechanics. Anybody interested in those courses? Oh, you're nuts. All right. Oh, okay. All right. Well, they're available for you. I didn't mean you're really nuts, yeah. But they're available. And for those viewing this, those may be the courses that you want to take. We will be, from what I understand, we have about the same number of students coming in the fall as that were here this year. And one advantage that we are finding is that we are hiring also 2 new teaching faculty members. They will be teaching lower level undergraduate courses. And because they're doing that, that frees up faculty, we're all tenured in computer, actually offer a lot more computer engineering courses. That's why this time, as you look up there, there's 10 courses up there because, for example, Dr. Sass is not teaching the computer organization course for juniors, and I'm not teaching 2181, which is Digital Logic 1 for sophomores. And Dr. Willis is back from sabbatical. That's another good course, Digital Signal Processing. And depending on what you're looking at, he tells me he's going to be doing a robotics course in the spring. And this will be more of a robotics course for using ROS for SLAM. All right, Robot Operating System for simultaneous localization and mapping. So if you're interested, save your hours for the spring semester 2017. As always, take care of identifying the actual time of these classes. Oh my gosh, there's 2 computer engineering courses offered at the exact same time. I'll have to talk to Dr. Adams about that. We shouldn't have 2 courses competing with each other. So I'll see if we can get that fixed. Oh, Dr. Cox is teaching controls. That's interesting. So do I have any questions from you about specific courses that are being offered? All right. Again, the advising form that I showed you earlier is required for students registering for their second and beyond semester. For those students just starting out, where fall semester is their first semester, you don't have to fill that form out. So I guess the next thing is to talk about, all right, what do you want to do when you grow up? And again, people are snickering. People like me who still haven't grown up ask that question all the time. But for those of you who want to know, is there a life after grad school? The answer is, sure, why not? The good news is, are you familiar with this on the OPT front? Oh, well, you guys are on top of everything, aren't you? That the extension of the amount of time you could serve as an OPT is now 36 months. Somebody said 37 earlier, but 36 months, that's a lot of time. Oh, I forgot one last class that's being offered. Which one is that? Summer 2016. This guy called Conrad is teaching robotics. This course will be offered at 5 p.m. on Tuesdays and Thursdays. Very, very, very hands-on. It's a mechatronics course. Mostly we'll cover theory and applied instances of everything from getting a LabVIEW based robot to move, writing in LabVIEW, as well as building up small robots from scratch. Oh heck, we'll even play with Lego Mindstorms. And I don't know if you're aware of this, but you can program, you've seen those little toy Lego Mindstorms, right? You can program that with their own interface or with LabVIEW. So that's one of the more interesting ones. LabVIEW is a tool that's used by a lot of companies for running up test environments, especially for hardware test environments. So yeah, summer, I know some graduate students don't have enough money to pay for a summer course, but it's available if you are interested in it. So now comes the big question. So we're going to talk this advising. What do you want to do when you grow up? Or just get older, or in my case, get older and bigger. Go ahead, laugh. So, I know a lot of you have goals of getting your master's degree and going straight back to your original country, right? Yeah, because there's lots and lots and lots of jobs in India, from what I understand. That's not what I understand. From all the news articles, TV programs, and discussions with actually some of my colleagues in IEEE, they're generating or they're producing a lot of engineering students in India without the background, or I'm sorry, without the jobs to actually absorb all of the engineering graduates. So a lot of you are going to stay here in the US, and you are welcome to stay here in the US as long as you pay taxes. So what do you want to do? So you have to observe, or you have to think about what company or where do you want to work? And I'm talking more of company. Do you want to do processors? Do you want to build systems? Do you want to work in VLSI? Do you want to do programming? Do you want to work for a bank in their IT department? Do you want to work in research? Do you want to start your own company? These are all questions that you have to think about what you want to do, and what you're going to be doing now for the next year is going to determine how easy or difficult it is to find a job. Now, I should actually make a poll. How many of you already have a summer job lined up? You have one. Did you just get it, or have you had it for a while? Speak up.
Just 1 month back.
Okay, and it's with?
It's embedded systems, Halo Smart.
Oh, locally. Yeah, Halo was formed by some of my students. So, yeah, that's pretty good. So, right now I'm hearing a lot of people getting interviews. And a lot of people are getting interviews based on the courses they have already taken. But of course, if you're going to go on and get a master's degree and work somewhere here in the US, you need to have a good story to tell. So the projects in your classes is one thing. If you work on a thesis or project is going to also determine how valuable you're going to be for a company. And you could distinguish yourself by working on a thesis, because working on a project for working on a small project as your master's degree type of degree may get somebody's attention, but it's the thesis that will really get a company's attention. So maybe I should step back and say some things as, where do you want to work? And of course, how will you get there? So the determination of this will be not only the courses you do, but also the projects you do in courses, but also what your MS degree path is going to be. And here, as you know, it is coursework, project, and thesis. I personally did the coursework only option when I got my MS in computer engineering from North Carolina State University. I had no intention on getting a PhD. And it is to my disadvantage that I did that. If I'd done a thesis, I would have been better prepared for working on my PhD. So if you're thinking about a PhD, you seriously might want to consider thesis option. Now, a lot of people will do a project just so they can distinguish themselves from other people with a substantial project, not a project that you're doing in a course, but a more substantial project that you're doing for a faculty member. And of course, if you do coursework only, I've actually had a lot of students say they wanted to do project and then move off into coursework because they actually got summer jobs and they wanted to get out as fast as possible. So in some cases, one of those courses that they're taking is a co-op or internship course, and then they've taken 9 other courses, and they already have a position, and so you may want to think about moving from project to coursework at some later time. Now, for this class, I think I have discussed what each of these is, right? What you have to do for each? Yes? No? Yes. All right. I'll tell you what, for the recording, I'll do this really quick. Thesis, 7 courses, and then 9 hours of research, 2 years. If you do a project, is equal to 9 courses, a project course, and this takes 1.5 to 2 years. Coursework only is 10 courses and test, and that's equal to 1.5 to 2 years. Now, a lot of people can get out of here in 1.5 years, but I also notice that a lot of people like to stick around for one more semester, so that during their last semester they take 3 hours, either one course or the project or something like that, and then they're spending a lot of time looking for jobs, or a job. You only need one job to work, right? And so there are 2 caveats. This one and this one means that you must have a faculty advisor. At our university, we have so many master's students compared to PhD that you can expect that if you are an MS student, you will not get no TAs and rarely a research assistantship during your first year. Some of you will get it though. However, during your year 2, there may be some TAs available and some research assistantships available to work on that. So I know, for example, Dr. Nazapuri is funding a couple of students. I have funded a couple of students, maybe a semester, and I know several who are getting TAs, like our cameraman in the back. So there is some support available. Of course, a lot of you are also working in individual jobs. But the reason why I say this is that, at least for computer engineering, there's a whole lot of you and a whole few of us in computer engineering. So, for example, now there's only 4 tenure-track faculty in computer engineering, and there are, I hear, somewhere between 100 and 125 computer engineering-minded students in our program. So, I'm doing my share, but a lot of you have also taken, decided to do the coursework and maybe shift into project if that happens. All right? So again, where do you want to work? How do you want to get there? Means that if you identify that you want to work at Intel, then you better take courses like VLSI, and research tools and techniques would be helpful. And actually, I think advanced embedded operating systems would be helpful too. If you want to work for a company that does applications, especially in the communications realm, well, you might want to take real-time operating systems and advanced real-time operating systems, and wireless sensor networks and analog and digital communications. If you want to build systems, mostly embedded system devices, like phones and the display product that we're working on, then obviously you need to look at Internet of Things and research tools and techniques, and of course embedded systems, and maybe some other ones. If you want to work in robotics, you want to look at control system theory, the robotics course, operating systems would help, and on and on and on. You have to look at where you want to work and what courses would be appropriate for that. Now, along with the course, you have to think about what faculty member works in that area, and if they are willing to take you on. Just because you're not going to get paid doesn't mean you can't do a project course. It turns out to be time. Does the faculty member have time to work with you? So you need to talk with that faculty member in particular. All right? And as I've mentioned to you, well, this is more for the people in the camera, I don't talk to anybody until they've been through here through one semester, and I could see how they're doing in my advanced embedded class. So with that, I've covered everything that I want to discuss in advising. Do I have any questions from you out there? Wow, none? Yes, ma'am.
How difficult is it to get like a PhD later on if you just do coursework, just because the courses will help you? Because thesis lets you do only 7 courses.
Correct. And as I mentioned that, I haven't mentioned, but I've had several students who have gotten a thesis and have worked in industry and have thought about getting a PhD, and actually 1 or 2 of them actually are pursuing a PhD, all right? But you can pursue a PhD without doing a thesis. I did it. Actually, if you know Ben Rhodes, you familiar with Ben Rhodes in my lab? He did coursework only. Sam did a project. And do you remember Tyler Major? He's talked to you as well. He is pursuing a PhD, and he did a thesis. So we've got the whole gamut. So it turns out, why would you like to take lots of courses? Well, one of the reasons why is you get to taste a lot of different types of courses, different types of materials. Some companies really like that. On the other hand, some companies, maybe Intel or someone like that, wants to see a nice big juicy completed project that you did or completed thesis that you did, that they want to take your expertise, put it in there and be very helpful in one particular area that was really similar to what you did on your thesis. So it really depends on what you're looking at. Talking to a lot of different people at companies is very helpful to find out where, which direction you should go. Did that help? Did I answer your question? Okay. No other questions? So you all know which courses you're taking next semester? All right. That is, do you have any advice for people who might be seeing this out there? I hear it. All right. Here's a question. How many of you worked in a job your first semester here? On campus? All right. Raise your hand high. Not too many? Well, about a third. Is it because you couldn't find a job or you didn't want to do a job? All right. Who couldn't find a job on campus? Who didn't want to do a job? All right. So it looks like more people chose not to and concentrate on your coursework the first semester, right? By the way, I always advise 3 graduate courses a semester. If you take 4, you won't sleep. Anybody taking 4 this semester? How many hours are you sleeping a night?
Not sure.
Not sure? Maybe about 4? Yeah, you got lots of sleep last week because we had spring break, right?
That's all I did.
You slept, you were like a bear. You slept the whole time, right? Okay. Any other advice you think I should offer them? How about this? Should they arrive really early, like early August to get acclimated, or should they cut it really close? Who says early? A couple of you. Who says cut it really close? Who's not telling me anything? That would be the rest of you. We had as many people saying early or not. The Indian organization here was very helpful from what I understand. And they always are, and rely on the existing graduate students who may be here for any assistance. With that, thank you very much.